This video is part of our complex numbers in polar form notes for 6-5 day 4. Here are some of the learning targets. I can find the powers of complex numbers and I can find the roots. So here's our example 8 where we want to find the power of a complex number. So we want to find 1 plus I raised to the 8th power using our Demoivre's theorem. And we want to write our answer in rectangular form. So to help us out, I did put our graph of our complex number. So this is what the graph looks like. Remember, this is in rectangular form, where we're going 1 to the right and then 1 up. This is our A value and that's our B value. All right, and we are going to raise that complex number to the 8th power. So we want to first find out what is the radius here. How long is that? So if you remember back to our previous lessons, to find that R value, you're going to use this equation, the square root of A squared plus B squared. And we talked about this is our A value and that's our B value. So our A value is the distance on the real axis of 1, so 1 squared. And the B value is the distance on the imaginary axis, which is also 1. And then we simplify that. 1 times 1 plus 1 times 1 is the square root of 2. So this distance from the origin to your complex number is a distance of the square root of 2. The second thing we need to do is we need to find out what is this angle theta. So to do that, we use this equation. The tangent of theta is equal to B divided by A. So we've done that already in our lessons. So we substitute our B and our A in. So the tangent of A is 1 divided by 1, and then we're going to use inverse trig. Theta equals the tangent inverse of 1. And we're going to keep this angle in radian measure, so you can use your calculator if you want, but our angle theta is 45 degrees, or in radian measure, pi over 4. So this angle is pi over 4. Falls in quadrant 1. Now we're going to go ahead and extend this page here, which I'm having some difficulty with in this screen cast-o-matic. Just give me a minute here. All right. So we know the radius and the angle measure for this complex number. Now we're able to change it to polar form. So remember, in rectangular form, A plus BI was 1 plus I. To change to polar form, you're going to use the formula R quantity, the cosine of the angle, plus I, the sine of the angle. So let's substitute in. That radius we found up here to be the square root of 2. It's the distance from the origin out to that complex number. Parentheses, cosine. The angle theta is pi over 4, so you substitute pi over 4 in. Plus I, sine of that angle, pi over 4. So this is our complex number in polar form. Now we're going to go ahead and raise it to the 8th power. That's what it's asking us. So now we're going to go ahead and use our theorem, our Demoivre's theorem, which was on a previous video. So we're going to use our theorem to raise it to the 8th power. So we're going to find out what is z to the 8th. So the square root of 2 cosine of pi over 4 plus I sine of pi over 4. And we're raising it to the 8th power, multiplying it 8 times. So we're going to go ahead and use that formula. So you can refer back to it in your notes if you'd like. So the first thing we do is we take that radius of square root of 2 and we raise it to the 8th power. Then quantity, the cosine of 8 times your angle theta plus I sine of 8 times pi over 4. And now we're going to simplify it. So the square root of 2, 8 times, looks like this. Well, this becomes 2, this is 2, that's 2, and that's 2. When you multiply those, now 2 times 2 times 2 times 2, you're going to get 16. I'm going to wait and just write it 2 to the 4th for now, and then change it to 16. So I'll do it in 2 steps. All right, now we're going to go inside the bracket and simplify the cosine of 8 pi over 4. So that's 8 pi divided by 4 plus I sine of 8 pi over 4. Continue simplifying. We simplified that 2 to the 4th, which is 16. And now cosine of 8 pi over 4, 8 pi over 4 is 2 pi. Plus I sine 8 pi over 4 is again 2 pi. So here is our vector in polar form. So z to the 8th in polar form. It's asking us to write our final answer in rectangular form. So then we have to use our unit circle. We need to evaluate for the cosine of 2 pi and the sine of 2 pi. So you think about your unit circle, 1 revolution around, here's our angle 2 pi. That ordered pair is 1, 0. The 1 represents the cosine of 2 pi, and the 0 represents the sine of 2 pi. So now we're going to substitute those values in. So this is going to become a 1, and that'll become a 0. So z to the 8th is 16. Replace the cosine of 2 pi with 1, plus I, the sine of 2 pi is 0. Continue simplifying. Z to the 8th is 0 times I is 0. So you're going to be left with z to the 8th, which is 16, or 16 plus 0i.